In this lesson, we're going to go over some basic problem solving. We're going to start by translating phrases into algebra and then move on to some applications. Let's first look at some commonly used words and what operations they relate to in algebra. So addition, we see a lot of times added, plus, and, total, but sometimes you'll see phrases like increased or more than, and especially sum is always something that we need to think of addition when we hear it. Subtraction, we see subtracted, we see minus, take away. All of those should be pretty common. Ones that you may not see as much are fewer, decreased, less, fewer, or difference. For multiplication, we see times and multiplied, but factor, multiple, and product are also words that should ring in multiplication in our ears. For division, we see phrases like per, ratio of, divided by, split up, quotient of. Anytime that you are breaking something up, think of division. And lastly are phrases that will mean our equal sign. Is, will be, yields, results in. Those types of phrases are going to be our equals. So let's start by translating phrases into algebra. We're going to use X to represent the input and Y to represent the output. My first phrase is 5 times the input increased by 7 is the output. So 5 times the input is going to say multiplication. 5 times my input, which is X, increased by, so I'm going to add 7, will be equals my output, which is Y. My next phrase is twice the sum of the input and 9 results in 18. Twice the sum. So I'm multiplying 2 by a sum. So that means my sum has to go in parentheses because 2 isn't just multiplied by my input or by the number, it's multiplied by the sum of the input and that number, which is 9. And that's going to result in 18. Our next phrase is half the input plus 8 is 65. So half my input means I'm multiplying X by 1/2. Plus 8 is 65. Phrase 4, the difference of the input and the opposite of 7 yields 17. So difference is going to be subtraction of the input and the opposite of 7. So the opposite of 7 is -7. And that yields 17. Lastly, we have 4 less than 3 times the input. Now our instincts may say, well, 4 less than means subtraction. Or you might say, oh, that sounds like this. Okay, they're both wrong. 4 less than 3 times the input means that we're taking 4 away from 3 times the input. So we're taking 4 away from 3 times the input. So 3 times the input has to be first. If you remember back from our lesson on the commutative and associative properties, the order matters when we're talking about subtraction and division. So here we have to be very careful that we're writing the order correctly. It's not the second phrase because in order for it to be the second phrase, I need that word is. 4 is less than. Since is isn't in the phrase, it's not this either. 3x minus 4 is the output, which is y. Phrases like 2 and 5 can be tricky, so that's why you want to read them through a couple times before you write them, and make sure after you write them to look back to make sure that they make sense. Let's take a look at our first example. You cut a piece of wood into 2 pieces so that one piece is 24 inches longer than the other. The longer piece is 4 times as long as the shorter piece. How long is each piece of wood? So my x that I'm looking for, my variable, I don't have to use x, but we use x because it's familiar and it's easy for us to remember. Our x is going to be the length of the shorter piece of wood. Okay, the reason why it's the length of the shorter piece of wood is because the larger piece of wood is being compared to that. We have two phrases that compares the longer piece of wood to the shorter piece of wood. So I have my two pieces of wood. I know that this piece is 24 inches longer. So that means I'm adding 24 inches to the length of the shorter piece of wood. What I also know about that longer piece of wood is that it's 4 times as long than the shorter piece of wood. So what this means is that this length represents the longer piece of wood, and this length represents the longer piece of wood. So they actually equal each other. So I'm going to solve this equation in order to find what the length of each piece of wood is. I ran out of room here on the bottom, but I'm dividing each side by 3. So I have x is equal to 8. So that means the shorter piece of wood is 8 inches, and the longer piece of wood is 32 inches. Again, I found the longer piece of wood because I just multiplied it by 4, or added 24. In my next example, I have you and a friend are canoeing down Cedar Creek. You both start at the same point, but you leave 30 minutes earlier paddling at a rate of 5 miles per hour. Your friend is paddling 6 miles per hour. How many hours will it take for you and your friend to catch up to you? So we actually need a formula that you may or may not remember from pre-algebra, and that's distance is equal to rate times time. Time here is always in hours, and my rate here is going to be in miles per hour. And my distance would be in miles. Well, I know that you and your friend are going the same distance. You start at the same point, and your friend's going to catch up to you. So that means that you're going to end at the same point. So your distance and your friend's distance are going to be equal to each other. You're paddling 5 miles per hour, so that's your rate. Now your time is going to be the number of hours it takes your friend plus a half an hour, because your friend left a half an hour later than you. Notice here how I didn't write 30, I wrote 0.5 because my time is in hours. So I have to write that 30 minutes in terms of hours as well. My friend is paddling at 6 miles per hour, and it's going to take X hours for them to reach me. I can now solve this equation. 5x plus 2.5 is equal to 6x. So 2.5 is equal to x. So it takes my friend 2.5 hours to catch up. You decide to start a business creating websites for different companies. It costs you $4,500 for a new MacBook Pro and the software, and it costs you $150 to design each website. For now, you'll be working from a home office, so there's no cost to rent an office space yet. You plan to charge $750 to your clients for each website designed. What are the total fixed company startup costs that you incurred? Well, you had to pay $4,500 for the new MacBook Pro and the software. So your fixed costs are $4,500. We now want to write an expression that represents the total costs that you pay designing X websites. Well, I pay $150 to design each website. Plus, I also have the $4,500 that I had to spend to get the software and the computer. So my total costs are 150x plus 4,500. We now want to write an expression that represents the revenue you earn designing the X websites. So the revenue is just how much money we're bringing into the company. If I'm charging $750 for each website, my revenue is 750x. Next, we want to write an equation that represents the total profit you earn designing X websites. So profit is equal to the revenue, so the amount of money that we bring in minus the cost. So profit here is 750x minus my total cost, 150x plus 4,500. And we can simplify this expression. We would distribute the negative sign and then combine the like terms. So my profit is 600x minus 4,500. So we make $600 for every website we create, and then we have to subtract the 4,500 for the computer and the software. What is my total profit if we design 5 websites? So again, our profit equation is 600x minus 4,500. So my profit is equal to 600 times 5 minus 4,500, which gives me a negative profit. So I lose money if I only design 5 websites. We want to know what is the total profit if we design 10 websites. So let's see if we make any money if I design up to 10 websites. My profit is equal to 600 times 10 minus 4,500. And I do make some money here. I make $1,500 if I design 10 websites. How many websites would you have to design if I wanted a profit of $15,000? So if I want my profit to be $15,000, we need to figure out how many websites we need to create. So I could solve this equation. I would add 4,500 to both sides, which gives me 19,500 is equal to 600x, and divide each side by 600. So x would be 32 and a half websites. So in reality, we would need to create at least 33 websites to get that $15,000 that we're looking for. So in this lesson, we talked about translating words into algebra, and then we used those skills in order to solve some applications. In the next video, we're going to talk about solving applications that have a bit more information and how we can use tables in order to help us create equations in order to solve.